Hi, how's it going? I'm really glad you're here. In this tutorial, we are going to use the analogRead function. We're going to take the raw data that we get, and then we're going to convert it into an actual voltage value. So what we want to know is what is the actual voltage being applied to one of the analog pins on our Arduino board. Now, in order to do this, we have to learn a couple things. The first thing you're going to learn is how to use a conversion factor. It's actually extremely simple and extremely handy, and we're just going to kind of talk through how to do some conversions. And the other thing we're going to do is learn about the float data type. Turns out also to be extremely easy. Now, before we jump in, I want to note that this sketch is very much like the last tutorial about using analogRead. So we will run into a couple new things, but it should be very familiar to you. But we're going to go from start to finish. It'll give you some repetition, and then it'll also put this new stuff in context. All right, so without further ado, let's go ahead and jump in. For this tutorial, you're going to need an Arduino. You can use any Arduino. I've got the Uno here, or you could use a clone. I do recommend sticking with the Arduino brand, however, just so we're on the same page. You will need a potentiometer. So potentiometer, it's like a volume knob. It turns left and right, and it really doesn't matter what resistance level you get. I'm using a 10K potentiometer here. You're also going to need at least 3 jumper wires, and then finally you'll need a solderless breadboard. So let's go ahead and set up this circuit. Alright, so here's our schematic. So you can see this is a really simple circuit. If you adjust your breadboard and your Arduino like we have in the schematic, then we'll be talking the same language as we go through this whole sketch. So you see the potentiometer, like the part that you turn is pointed away from the Arduino, and 5 volts we have connected to the left side of the potentiometer. Ground is attached to the right pin of the potentiometer, and then the center pin of the potentiometer, that is what goes to A0, which is the first analog pin on your Arduino. So what's happening here is the potentiometer is acting like a voltage divider. So on one end of the potentiometer you've got 5 volts, and on the other end you have 0. And when you adjust that knob, the center pin is going to change all the way up from 5 volts down to as low as 0 volts. So as you adjust that knob, you are adjusting the amount of voltage that's going to be seen at that center pin, which ends up being, what we have on our Arduino attached at A0. Okay, so that's essentially how this is working. So go ahead and open up your Arduino IDE and go to File, Examples, Basics, Read Analog Voltage. Alright, so the first thing that we come to, the first block of code, are the comments. We've got a multi-line comment. It talks about how to set up the circuit, and it talks about just roughly how the circuit works. It also lets us know that the code is in the public domain, so we know we can pretty much do whatever we want with this code, which is a good thing to know. So that's it. We don't declare any variables, so there's no declaration or initialization of variables. And so if that's not there, it looks like we jump right into setup. So in setup, all we do is we use the begin function from the serial library to initialize our serial communications, and we send a baud rate of 9,600. Again, that is the standard baud rate communication that you'll be using. And that's pretty much it for setup. Not too much to set up here. So beyond setup, now we get to the loop. So the loop again is going to run over and over and over again, as opposed to setup, which only gets executed once. So we're in the loop. It's kind of the meat and potatoes of what's going on. So let's take a look. What do we see that's going on here? So the first thing we've got here is a variable initialization, or declaration and initialization. So we've got a variable that's named sensor value. It's an integer, and we are initializing it to the output of the analogRead function. So if you recall from the last tutorial, analogRead can be used on the analog pins on the Arduino. So those are A0 through A5. There's 6 analog pins. And all we're doing is passing analogRead the number of the pin that we've hooked up the center pin of our potentiometer to, which happens to be A0. So the first pin is A0, the last pin is A5. So that's how you reference it. You put an A and then the number of the pin. Now, the output, if you recall, of analogRead is going to be an integer between 0 and 1023. So 0 is going to refer to 0 volts, and 1023 is going to refer to 5 volts. So that's handy. So basically, generally handy. So basically, when you turn your potentiometer, if you turn it all the way left, it's going to be at ground, which would be 0. And if you turn it all the way right, it's going to be at 5 volts, which is going to be 1023. Let's say we're not interested in that generic number. Let's say we want to actually know what the voltage value is. Well, we have to do a conversion on that number. So again, what this line of code is going to do is it's going to give us the number between 0 and 1023. But to get that actual voltage number, we have to go on to the next line of code where we do a conversion. So let's go ahead and talk about the conversion. So let's talk about basic conversion. Now we are going to do a little bit of math, but I promise you this is the only math you're going to run into in this entire course, and it turns out to be extremely easy. So the first thing I like to do is kind of get in my head, what is it that I want as my output? What am I trying to convert to? So in this case, we're given units. All right, so we're giving like these generic units. The number that we get from analogRead is between 0 and 1023, like I've already said 4 times. All right. But what we want is volts. So what we need to figure out is how many volts are there per unit. Okay? So let's go ahead and jump into this algebraic expression. Okay? So on the right hand side here, I've got my known. I know that if I've got 0 resistance on the potentiometer, so I'm not dividing any of that voltage up, I've just got 5 volts going straight to analog pin A0, I know that I'm going to get 1023 units. So I know that 5 volts gives me 1023 units. But what I want to know is how many volts do I get per X units. Okay, so that's what I'm trying to figure out. So how would we set up that equation? Well, if we want to know how many volts, and we want this to be on its own on the left-hand side of the equation, all we have to do is multiply by X units. So all I do is I put the X up here and the X up here. These are going to cancel out, and we're going to get something that looks like this. So now I've got number of volts on the left, X units times this conversion factor, 5 volts over 1023. Okay, so what this is going to do, notice that units will cancel out, and we're going to be left with volts. So this number right here, well, what is this X? Well, this X is what we're going to get as the output from analogRead. Okay, so this is going to be a number from 0 to 1023. Okay, so this number is going to get multiplied times this conversion factor, and we'll end up with volts. And then that voltage will get assigned to this value right here. So that's basically how to do a conversion. So remember, start out with, well, what is the unit that I want to end up with? In this case, it was voltage. And then ask, well, what are the knowns? What conversion factor can I use to cancel out the unit that I don't want? Okay. All right, so that's it on conversion. Let's go ahead and jump back. So let's go ahead and drop down to this next line of code where we set up this conversion factor. All right, so again, we've got we've got a declaration and an initialization. So we've got float. Whoa, float. Hold on a second. What is float? Well, float is just a data type. I'll talk about that in a moment. But let's just pretend that we know what float means, okay? So float, it's a data type. Well, what's the name of this variable? It's called voltage. Great name. Clearly says what we want, voltage. And we initialize it to, now this is where that equation from the conversion we just talked about. Sensor value. Well, that's our X. That's what we just assigned. Sensor value is the value that's coming right out of analogRead, and it's telling us where exactly our potentiometer is turned to. And then what do we multiply it by? Well, we multiply it by our conversion factor. Again, that's 5 volts divided by 1023 units. Again, so 5 volts per 1023 units. Okay, so voltage is going to be the actual voltage that gets applied at the pin. So before we move on, let's go ahead and talk about this float data type. So a float, it's a weird name, but really it's really simple. So a float is simply a number that has a decimal point. So like 3.141592, that has a decimal point. So any number with a decimal point, 2.00, 2.10. Those are examples of floating floats. They're also called floating point numbers. So like I like to think of a float. I think of the little, the decimal point is like a raft floating in the ocean. It's just kind of bobbing around. So it's floating. It's a decimal. It's floating in between the numbers somewhere. That's how I remember it. So it can be really big, like 3.4 times 10 to the 38th big, which is a decillion. That's like 38 zeros on the end of your number. So that's huge. Now, it's only precise to 7 total digits. And that's not 7 digits to the right of the decimal point. That's actually 7 digits total. Now, floating point math is actually really slow. So if you start trying to multiply, add, divide, all that type of stuff with floating point numbers, you are going to slow things down. So I would avoid it at most cost. Now, sometimes it's necessary. In this case, we're using it, but definitely try to minimize it. And floating point options, they can actually return some pretty obscure results. Now, there are some workarounds. Usually that involves changing a float into an integer and then doing your math. But generally, it's not good to do comparisons with floats because you just don't know what you're going to get. So, or between floats, for example. But, that's really, we're not too worried about that. It's maybe a little more than you need to know about a float. But just so, again, let's just recap real quick. Floating point number, it's a number with a decimal point. Well, what does that mean to you, or us rather? It means that it's a number that has a little more accuracy than an integer. Okay, so that's it with float data types. There's always more to read about if you want to check more out in the further reading. So let's go ahead and recap the loop function. So the first thing we do, we declare a variable, sensor value, and we set it equal to the output of the analogRead function. So we're going to be getting raw data from analogRead. Then we declare another variable called voltage, and we set it equal to that raw data times that conversion factor that we set up. So now voltage is going to end up as the actual voltage being applied at our pin. And then what we want to do, we send it to the print line function from the serial library. And why do we do that? Well, we want to be able to see it. We can use our serial monitor on our Arduino IDE and check out what the actual voltage is. And then the loop repeats itself. It looks at analogRead, so we're checking out what our potentiometer is set at again. Again, send that raw data to voltage, convert it, and then print the output. Do that over and over and over again. So let's go ahead and verify the sketch, and let's upload it. And now let's go Tools, Serial Monitor. Okay, so right now I'm at 5 volts. I'm going to go ahead and adjust it to the left. Now you can see the voltage number changing. We've got 2 digits of accuracy here, so you can see we've got a floating point number as the output, and now there I'm at 0. Okay, so somewhere in between should be 2.5 volts. Okay, so now you can see we've converted that raw data from analogRead into the actual voltage number. Pretty cool. There's a lot of uses for this, especially when it comes to testing what voltage you're actually getting in off a sensor. So that's one good reason to implement this type of conversion. Okay, that's it. I look forward to seeing you at the next tutorial, and be sure to do the try it on your own challenge. That's where you're really going to learn something. All right, see you next time. Have an awesome day.